Here are some tiles on a square grid. 3 different tiles can be fitted together without overlapping to make a shape identical to tile A. Write the letters of the 3 tiles. So if we take tile B, we can move that here. We can take tile G and move that here. And we can take tile C and move that here. So we've used 3 different tiles. They don't overlap and they make a shape identical to tile A. So the tiles that we've used here are B, C and G. Here is a shaded rectangle. What are the coordinates of B? So we need to find the coordinates for this point here. We have other points that do have coordinates, and we know that the first number of the coordinates tells us the value of x. The first coordinate is the x coordinate. So often with coordinates questions, what helps us is to put what we know on the axes. So if we take this point here, we can see the x coordinate is 2. That's in line with this point here. The x coordinate is 2 for point D as well. So we can write 2 on our axes. Now, if we look at point B, we can see that that's in line with point C, where the x coordinate is 8. So that means the x coordinate for B is 8 as well. Now, if we look at the y coordinate, so the second number, here we have 3. That's in line with point M and point D, so the y coordinate of 3 we can write on our axes. And now for point B, we can see that that's in line with point A, where the y coordinate is 7, so we can write 7 on our axes, and we know that the y coordinate for B must be 7. Now, M is halfway between D and C. What are the coordinates of M? So we have point M here, and we don't know what the x coordinate is, but we do know that it's halfway between D and C. So the x coordinate will be halfway between 2 and 8. So that means the x coordinate will be 5, because that's the number right in the middle of 2 and 8. So we can write 5 as our x coordinate, and then we can see that our y coordinate will be 3, because that's in line with point D and point C, which both have a y coordinate of 3. Complete this table to show the numbers rounded to the nearest hundred. One has been done for you. So 316 rounded to the nearest hundred is 300. Now we need to round 3,162 to the nearest hundred. To do that, we need to find our hundreds digit, and that's always the third digit from the right, because we have ones, then tens, then hundreds. To decide whether we're rounding up or down, we look to the right, so we look at our tens digit, and if it's 5 or more, like it is here, we round up. So that means this 1 is going to become a 2. Digits to the left stay the same, so the 3 in our thousands stays the same, and digits to the right of what we've circled turn into zeros. So we have 3,200. Now we need to round 31,628 to the nearest hundred. So again, we find our hundreds digit and look to the right. It's a 2, and if it's 4 or less, like it is here, we round down, which means this number stays the same. Digits to the left of what we've circled always stay the same, and digits to the right turn into zeros, so we have 31,600. And now 316,281. We find our hundreds digit, look to the right, and because it's 5 or more, we round up. And when we round up, the digit that we've circled increases by 1. So this 2 is going to become a 3. The 3, 1, 6 at the start will stay the same because digits to the left stay the same. Digits to the right turn into zeros. So we get 316,300. Here is a diagram for sorting numbers. Write these 3 numbers in the correct boxes. You may not need to use all of the boxes. So we have the numbers 9, 17 and 20. So let's start with the number 9. First, we need to decide whether it's prime or not prime. So we need to remember that a prime number only has 2 factors. A prime number is only in the 1 times table and its own times table. But 9 is not a prime number because it's in the 3 times table as well. The factors of 9 are not just 1 and 9, but 3 as well. So it's not prime, which means we now need to decide whether it's even or not even. An even number is a multiple of 2, so a number that ends in 0, 2, 4, 6 or 8. So 9 is not even, which means we can write 9 in this box here. Now let's work out where we can write the number 17. 17 is a prime number because it's only in the 1 and 17 times tables. It only has these 2 factors. It doesn't have any other factors. So 17 is a prime number. And 17 is not even because even numbers end in 0, 2, 4, 6 or 8. So 17 is an odd number. So 17 can be written in this box here. And finally, we have the number 20. That's not a prime number because as well as 1 and 20, 20 is also in the 2, 4, 5 and 10 times tables. But 20 is an even number. It's a multiple of 2 and we know that because it ends in a 0. So 20 goes in this box here. Write in the 2 missing digits. So we have something times something equals 3,000. And both of the numbers that we're multiplying have a ones digit of 0. So these numbers will be multiples of 10. Now remember the rule for multiplying multiples of 10. We have one end 0 here and another end 0 here. So that's 2 end zeros altogether, which means we will have 2 end zeros in our answer. So now we've really got something times something is 30, and 6 times 5 is 30, so we can have 6 and 5 in any order as our missing digits. 3/4 of a number is 48. What is the number? So 3/4 of something is 48, and we know that normally to find a fraction of a number, we divide by the denominator and then multiply by the numerator. So divide denominator and times top. But here we have a missing number problem, so we need to do the inverse. Instead of dividing by the denominator, we can instead divide by the numerator, and 48 divided by 3 is 16. So then we can take that answer and multiply by the denominator. Remember, normally it's divide denominator, but because it's a missing number problem, we're going to do the opposite. And 16 times 4 is 64, so that's our number. And here we might need to use short division to divide or short multiplication to multiply. But we know that our number is 64. We can check that it works because if we take 64 and divide by the denominator, 64 divided by 4 is 16, and then we can take that and times top, so multiply by the numerator, and that gives us 48. Again, we might need to use short division or short multiplication to work this out. Write these fractions in order of size, starting with the smallest. So we have 3/4, 3/5, 9/10, and 17/20. But to compare fractions, we need the denominators to be the same. So we need to find equivalent fractions. Now 20 is in the 4 times table, it's in the 5 times table, and it's in the 10 times table. So we can find equivalent fractions which have a denominator of 20. To do that, we use multiplication. 4 times 5 is 20, and what we do to the denominator, we do to the numerator as well, and 3 times 5 is 15. Now 5 times 4 is 20, 3 times 4 is 12, and 10 times 2 is 20, 9 times 2 is 18. So that means our smallest fraction is 3/5, because that's the same size as 12/20. Then we have 3/4, because that's equivalent to 15/20, then 17/20, and our largest fraction is 9/10, because that's the same size as 18/20. This jug has 1 litre of water in it. Lauren pours out 400 millilitres of water. Draw an arrow to show the new level of water in the jug. So we know that 1 litre is the same as 1000 millilitres. So what we need to work out first is what each of these little lines on our jug represent. To get from 0 to 1000, we have 1, 2, 3, 4, 5 jumps. So if we divide 1000 by 5, that gives us 200. So each of these lines represents an increase of 200 millilitres. So we have 200, 400, 600, 800, and then 1 litre is 1000 millilitres. But we don't want to draw an arrow to show 400, because Lauren pours out 400. So she starts with 1000 and then pours 400 millilitres out. And 1000 minus 400 is 600. So once she's poured out 400 millilitres, the new level of water will be at 600 millilitres. So we need to draw our arrow here. This statement is not true. A multiple of 10 added to a multiple of 10 always makes a multiple of 20. Give an example to show that this statement is not true. So a multiple of 10 is a number that can be divided by 10 without giving a remainder, so a number in the 10 times table. And a multiple of 20 can be divided by 20 without giving a remainder, so that's a number in the 20 times table. So if we have 30 plus 20, 30 and 20 are multiples of 10 because they're numbers in the 10 times table. But that gives an answer of 50, and 50 is not a multiple of 20 because 50 is not in the 20 times table. If we count up in steps of 20, we have 20, then 40, then 60. We don't have 50, so 50 is not a multiple of 20. There are lots of possible answers for this question. So if the tens digit, one of them is odd and the other one is even, we'll have an odd tens digit of our answer. And for multiples of 20, the tens digit has to be even because multiples of 2 are always even numbers. An isosceles triangle has a perimeter of 12 centimetres. One of its sides is 5 centimetres. What could the length of each of the other 2 sides be? 2 different answers are possible. Give both answers. So an isosceles triangle is a triangle where 2 of the sides are the same length. And the perimeter of a triangle is the total of all three lengths together, because the perimeter is the distance around the outside of a shape. So we know that one of the sides is 5 centimeters. So we have 5 centimeters plus the two other lengths have to give a total of 12 centimeters, because that's the perimeter. And we know that two different answers are possible. Now with an isosceles triangle, two of the sides will be the same length. So if one of the lengths is 5 centimeters, another length could be 5 as well, because then we have two sides that are the same. So 5 plus 5 is 10, and that means the other side would need to be a length of 2 centimeters to give a total length, so a perimeter, of 12. But there's another possible answer, because rather than having two lengths of 5 centimeters, it's possible that these two lengths here, so the two unknown lengths, are the same. So we have 5 plus the two lengths equals 12. 12 minus 5 is 7, so these two lengths together must be 7 centimeters, and they're the same, so we can divide 7 centimeters by 2, and that gives us 3.5 or 3.5 centimeters. So it could be that these two lengths are the same. We need two of the lengths to be the same so that the triangle is isosceles, and then we have 5 centimeters as our longer length, because 5 plus 3.5 plus 3.5 is 12.